Hi, welcome to this instructional video by See Your Future. I will be discussing the question, how does magnetism work? To start, we should all understand the basic properties of magnets. Magnets can take virtually any shape, but for simplicity in this video, I will draw all the magnets as bar magnets. Every magnet has both a north and a south pole. The term poles comes from the fact that the magnet has polarity. However, this polarity is not the same thing as electric polarity. Positive and negative electric charges are able to stand on their own. However, a magnet must always have a north and a south pole. We can confirm this by breaking our bar magnet in half. The result of doing this is not two separated north and south poles. Rather, we now have two smaller magnets, each of which has both a north and a south pole. Lastly, it should be known that a north and south pole experience a force of attraction when they come close to each other, while either two north poles or two south poles will experience a force of repulsion when they come near each other. Thus far, I have not described why these poles exist. To understand this, we need to zoom in on a single atom of our bar magnet. There are several different types of metals that may be used to create a magnet. Our bar magnet, in this case, will be made out of iron, symbolized by Fe. To show how iron can be magnetic, I will draw a Bohr model of the atom. This is a simplified model that represents the orbits of the electrons around the atomic nucleus. Each ring represents a separate orbit that can only hold a certain amount of electrons. A neutral iron atom contains 26 electrons, each of which will be represented by a circle. The orbits closer to the atomic nucleus can hold less electrons. A simplified reason for this is that the inner electrons have less room to move. Most of the electrons in the iron atom exist in pairs. However, there are 4 electrons that orbit by themselves. These are the ones shown in red. An explanation as to why these electrons exist in this unpaired state would involve a more advanced discussion in quantum mechanics. However, to understand magnetism, it will suffice to simply know that these unpaired electrons exist. Now, imagine that each of these electrons is spinning as it orbits the nucleus. When 2 electrons are paired, they spin in opposite directions. Therefore, it can be said that their spins cancel each other out. However, the unpaired electrons do not have a partner to cancel their spin. Overall, the atom has 4 more electrons spinning in one direction than it does spinning in the other direction. The result of this phenomenon is that the atom is given a magnetic polarity. Just like our bar magnet, the atom itself has both a north and a south pole. This means that each iron atom can act as a very small magnet. Now, let's take a look at a bar of iron. This bar contains a very, very large number of individual iron atoms. In a typical bar of iron, these atoms can be oriented in any direction. Keeping in mind that each atom has both a north and south magnetic pole, the effect of the random directions of each of the atoms is that the magnetism of each atom is cancelled by all the others around it. Ultimately, even though all of the atoms that make up the bar are magnetic, the bar itself does not have any magnetism. To make the iron bar magnetic, all that we need to do is align all of the atoms in the same direction. This can be done by placing the bar in a pre-existing magnetic field. This will cause all the atoms to point their north poles in the same direction. This gives the bar the magnetic polarity that we discussed previously. Once the atoms are aligned, we can say that the bar itself has a north and a south pole, and we can now call it a bar magnet. In conclusion, it can be said that magnetism is created by the individual atoms that make up a magnet. I hope you enjoyed this video and that you found it to be helpful. If you have any questions about what was shown in the video, please type them in the comment box below. If you have a question on another topic, please send us an email at questions@syfuture.org. Also, take a look at our YouTube channel for a full list of instructional videos. You can access this channel through our website, www.syfuture.org. Thanks for watching.